One drop of blood, 200 tests. Theranos raised roughly $9 billion on that promise of finger prick drop physics made useless for most of it. The valuation soared. The physics never budged. This wasn't a lab demo. Real patients handed over a finger and got numbers back. Numbers that steered real medical decisions. Here's the part that should stop you. The flaw didn't stay in a garage. A soaring valuation and a Walgreens rollout pushed it into actual pharmacy clinics. Ordinary people trusted the results. So the whole story hinges on one decision that changed everything. The choice to sell a drop the body simply doesn't give you clean. Follow that and the rest makes sense. Start with the exact promise because it was dazzling. From one finger prick drop, Theranos said its machine could run about 200 different tests. No needle in the arm, no vials, just a pinprick you barely feel. Picture why that sounded revolutionary. Blood testing today is slow, a little scary, and tied to a lab. A normal test panel means a technician finds a vein. They draw one or more vials of venous blood pulled straight from a vein in your arm. Those vials ship to machines the size of refrigerators. Different tests often need different vials and different instruments. Now compress all of that into a countertop box at your corner drugstore. Less money. A drop instead of a draw. Cheap. Painless. Everywhere. That's the pitch that moves boardrooms. It maps onto something people already hate. Getting stuck with a needle. Kill the needle, and you kill the friction that keeps people from testing at all. Catch disease earlier, cheaper, closer to home. That's the future being sold. Here's the quiet problem hiding under the pitch. The promise wasn't just to shrink the machine, it was to shrink the sample. 200 tests were supposed to come out of a volume of blood smaller than a raindrop. That word, drop, is doing enormous work. Nobody in the room stopped to ask whether a single drop can even carry the information for one test, let alone 200. That question is where the whole thing quietly breaks. Which brings us to the drop itself. Now open the drop. Here's the thing almost nobody outside a lab knows. The blood from your fingertip is not the same stuff as the blood in your arm. When a technician draws from a vein, they get clean venous blood, a fairly pure sample of what's actually circulating in your body. When you squeeze a fingertip to force out a drop, you get something messier. That drop is a mixture. Part of it is blood, yes, but you also squeeze out interstitial fluid, the watery fluid that sits between your cells in the tissue itself. It's not blood, and it doesn't carry the same concentrations of things. On top of that, the pressure of squeezing ruptures cells. Red blood cells burst open, spilling their insides into the sample. Scientists call those broken open cells lysed cells. When a cell bursts, everything locked inside it, potassium, enzymes, proteins, floods into the drop. So think about what you're actually holding. A finger prick drop is blood, plus tissue fluid that dilutes it, plus the guts of ruptured cells that spike it. Every one of those effects moves the numbers. The measured level of a substance in that drop no longer matches the true level circulating in the patient. Here's why that's fatal for a diagnostic. A blood test is only useful if the concentration it reads is the concentration in you. Read potassium off a drop full of burst cells and you might see a dangerous number that isn't real, or miss one that is. The sample is corrupted before it ever reaches the machine. This isn't a bug you engineer away with a better box. It's the raw material arriving contaminated. Fix everything downstream and the drop is still wrong. So even a perfect machine starts with a compromised sample. And then Theranos had to do something to that drop that made it worse. Here's where the math turns cruel. Set aside contamination for a second and just count. One finger prick drop is a tiny, fixed volume, a few microliters, less than a raindrop. That's all you get. Now recall the promise about 200 different tests. Every single test needs its own minimum amount of sample to work. There's a floor below which the machine simply can't read anything reliably, so you can't run 200 tests on a volume that barely covers one. To spread one drop across many tests, Theranos did the obvious thing. They diluted it. Add liquid, split the watered-down mixture into many little portions, feed each portion to a test. It sounds clever. It's also self-defeating, and here's the mechanism. Every blood test hunts for a target substance and measures how much is there. The more you water down the sample, the fewer molecules of that target sit in each portion. Diluted enough, and the target drops below the machine's detection limit, the faintest amount it can still see. Below that line, the answer isn't wrong. There's simply nothing to read. The signal is gone, so watch the trap close. To hit 200 tests, you must split the drop. To split it, you must dilute it. But dilution thins the very signal each test depends on. The thing that lets you cover many tests is the same thing that destroys most of them. And it's worse for the tests that matter most. The ones hunting for substances that are naturally rare in blood, present in tiny amounts, even in a full vial. Water those down and they vanish first. This is the collision the whole company was built on top of. Physics gives you a fixed, tiny drop. Chemistry demands a minimum sample per test. Dilution can't create signals, only spread thin what little you have. No amount of engineering budges those three facts. The 200 test promise didn't need more work, it needed different physics. So what was actually inside the box? So picture the Edison machine itself, stripped of the mystique. Reporting and later testimony describe it as, at its core, a robotic pipette on a track. A pipette is the little tool that sucks up and squirts out precise amounts of liquid. Bolt one onto a moving arm, add cartridges in a reader, put it in a sleek black case, and that's the shape of it. An automated liquid handler in a nice box. Nothing about that is fake technology. It's real, and it works for what it can do. The problem is, what it can do is narrow. The Edison ran essentially one family of chemistry, immunoassays. Here's what that means in plain terms. An immunoassay uses lab-made antibodies, molecules built to latch onto one specific target. When they grab their target, they produce a signal you can measure, often a glow or a color change. It's one clever trick, and it covers a real slice of blood testing. But it is one trick. It is not 200 different kinds of testing, because the 200 tests on the promised menu don't all run on that trick. Counting your blood cells, how many red cells, white cells, platelets, is a completely different job. It needs a machine that sizes and sorts actual cells, not one that watches antibodies glow. Measuring basic chemistries like sodium, potassium, glucose relies on yet another method entirely. These aren't variations on immunoassay. They're separate instruments, separate physics, separate machines that a hospital lab lines up side by side. The Edison had one method and no way to become the others. So stack the failures. The sample arrives contaminated. Dilution erases most of the signal, and the box could only ever perform one type of test out of the many the menu listed. Even granting a flawless immunoassay, most of those 200 tests had no instrument inside that machine that could physically run them. There was no hidden lab in there, just one pipette doing one thing. Now line up the three walls because together they answer the whole question. Wall 1, the finger prick drop arrives contaminated. Tissue fluid and burst cells shift the numbers before any machine sees it. Cool. Wall 2, the drop is a fixed, tiny volume. To reach 200 tests, you dilute, and dilution thins the signal until most tests read nothing. Wall 3, the box ran one method, immunoassays, while the promised menu needed several different instruments it didn't contain. That's the decision that changed everything. Betting the company on a drop the body doesn't give you clean, and a box that can only do one trick. Here's the hard part. Stack those three walls, and the 200 test promise wasn't unfinished. It was impossible. Not a product running late, a claim that no amount of engineering, money, or time could ever reach because it ran into physics and chemistry, not a to-do list, and the billions funded exactly that unreachable claim. The proof came out later. According to court testimony and reporting, when the drop couldn't deliver, the company secretly ran many patient samples on ordinary commercial analyzers made by Siemens, the very fridge-sized lab machines it was supposed to replace. The magic box quietly outsourced to the machines it claimed to beat. That's what happens when a promise picks a fight with physics. Reality still sends the bill.
The lesson is uncomfortable and simple. Hype outran physics. Investors didn't just back a risky bet, they bought a promise the physical world forbade from day one. No valuation can pay reality to look the other way. Before you trust the next magic box, ask what physics allows, not what the pitch promises. Next, watch how a real PCR test actually reads your DNA. This video is history, not medical or investment advice.